Hello, everyone. Welcome back. First, let me sing a song for you. You are my sunshine, my only sunshine. You make me happy when skies are gray. You never known, dear, how much I love mathematics. Please don't take my sunshine away. Okay, cheer you. I try to cheer you up. And today we do section 4.2. 4.2, this is the ideas of K. Ito. From 1976. Okay, in the 1976 Kyoto Symposium on stochastic differential equations, K. Ito started his lectures with the following question. Yeah, I was in the symposium, so I remember he wrote down in the very beginning, he wrote down this: the integral from 0 to 1 of B1 dBt. Bt is, of course, our underlying Brownian motion. And he said that the integrand is independent of t, and therefore we can pull it out. And then the integral from 0 to 1 of dBt is B1 minus B0, which is B1. And so B1, B1, we have B1 squared. And then he put a big question mark here. Is this integral equal to that? That is the question. The second inequality, of course, is true. But the first inequality, is it true? Well, it all depends on the definition of the stochastic integral from 0 to 1 of B1 dBt. This looks fine, but in fact, note that B1 is not adopted. It's not adopted with respect to the filtration. Given by the Brownian motion Bt. Namely, it is this filtration. Ft is a sigma field generated by Bs for S between 0 and t. Okay, so the integrand B1 is not adopted with respect to this filtration. Therefore, this stochastic integral is not an Ito integral. It's not an Ito integral. And so, how do we interpret this integral? If we do not know the definition of this integral, how can we say this integral equal to b1 squared? In the lecture, Ito introduced the following ideas. One, the first idea is to enlarge the filtration. So that B1 is adopted. With respect to the new filtration. And this is the larger filtration that he introduced. I write this as G script G sub T. This is F sub T. This the enlarged filtration is GT. It is the sigma field generated by B1 and Bs for S between 0 and T. So this is T here, this T. And note that we threw in B1. So this is the larger filtration than FT. And obviously, with respect to GT, this filtration, the integrand B1 is adopted. So we change to another page, a new page. Now, but then, this is page 8. But then, BT and this filtration GT do not satisfy the assumption satisfy the assumption that assumption BT for any S less than or equal to T, BT minus BS and G sub S are independent. See this? They, they do not satisfy this assumption. This is a fundamental assumption in the Ito theory for the Ito integral. So this BT and this filtration, they don't satisfy this condition because obviously BT minus BS and GS, now this time GS include B1. So this random variable and this sigma field are not independent. And because they are dependent. But this the assumption that they are independent is a fundamental assumption for the Ito theory. Hence, the integral from 0 to 1 or B1 dBt is not an Ito integral. So then, how do we get around with these difficulties? You see, we not the filtration, but then the assumption for Ito theory is not satisfied, and so Ito has a second idea too. So the first idea is enlarge the filtration. The second idea is decompose the integrator. Decompose the integrator from the motion BT. Decompose this. So this is the decomposition. Write BT as BT minus the integral from 0 to t of B1 minus BU over 1 minus U du. And this is the first term. And the second term plus the integral from 0 to t of B1 minus BU over 1 minus U du. This is the second term. Now this is the fact. The first term is a martingale with respect to the enlarged filtration GT. Fact 2. The second term is a stochastic process of bounded variation. Hence, BT is a quasi-martingale. With respect to the filtration GT. And then the integral 0, 1, B1 is interpreted as a stochastic integral with respect to this quasi-martingale BT. And then that integral equal to B1 squared. I will put this as equation 1. So I stop now, and then I'll come back right away.